Hello, I'd like to welcome you to the Past Business Analytics virtual chapter. We meet a couple times a month, usually on Thursdays, and we've had a lot of different topics in the recent months. We've been working towards topics related to Power BI and the Power Tools. So for those of you out there that took the poll, we appreciate it. It helps the presenter gauge the type of content that he will be delivering. Also, a couple weeks ago, we asked you to take a poll, a survey monkey poll regarding the different topics that we'll be providing. So we'll soon be looking at that, and hopefully we'll use your feedback for further topics. The other person that's involved in this chapter, myself, is Melissa Demsak, and also Parish Doshi. He helps out with the marketing side. You've probably seen some emails from him. So it's just the two of us running it. So if you're interested in helping out with the chapter, let us know. Other thing of interest is the Past Business Analytics conference is coming up in May. If you haven't registered and you would like to register and get a discount for that, for this chapter we have a discount code of BAVC04. So I believe that will save you approximately $200. I'll have to go back and look at the literature. I'll post it in the window here as well. So I'm really excited today about Chris Webb presenting on his Power BI submission to the Microsoft's Power BI contest. He is one of the top 5 finalists for the contest, and I really thought it was valuable to see, real-life experience of how someone put something together, and it would be great for all of us to see, and hopefully it'll inspire us to get out there and create more Power BI projects. So I'd like to introduce Chris Webb, and he can tell you all about himself. Okay, Chris?
Thank you, Melissa. Normally at this point I would flash up a slide with all of my links and Twitter handles and everything on it. Maybe I'll dig one up at the end of the session. In this case, though, I have no slides, so I'd better introduce myself just by speaking. My name is Chris Webb. I am an independent consultant and trainer based in the UK, as you can probably tell by my voice, and I specialize in analysis services and MDX, and nowadays in all parts of the Microsoft Power BI stack. So Power Pivot, Power Query, Power View, Power Map, Power Everything. And obviously, as soon as Microsoft announced they were going to have a Power BI competition, I thought this is something I should enter, especially when I saw all the cool prizes on offer. And in this session, what I'm going to do is I'm going to step through how I built my entry for the Power BI competition. Now, like I said, there are no slides for this session. There isn't going to be any real structure or theme beyond me stepping through how I built my presentation. But I think it should be interesting nonetheless, because it shows you some of the compromises I think you have to make and some of the decisions that you have to make when you're building a real solution. It also means that we can focus in on some fairly obscure parts of DAX and other parts of the Power BI stack that you may not particularly go into. So it's not a general introduction to Power BI, Power Query, Power Pivot. I will try and explain what each part of the Power BI stack is when I come to it. I can't guarantee that everything will work perfectly. Hopefully at the end of the session I will be able to show off Power BI Q&A, the natural language processing part of Power BI. Unfortunately, when I was testing it this morning with my data, it was giving me errors occasionally. But if you keep your fingers crossed, if we all collectively keep our fingers crossed, then I hope that it will work okay. So, if you're sitting comfortably, I will begin. I'll begin at the beginning. The first question I had to ask myself when I was thinking about my entry for the Power BI competition is, where am I going to get some data from? And of course, in this day and age, there are tons and tons of interesting data sources available for free. In the UK, we're particularly lucky because the UK government is very, very committed to open data. And it's making more and more data available online through websites, data.gov.uk, which hopefully you can see in front of you right now. And this website, if we go...
Chris, we're actually not seeing your screen at this point.
Sorry. Let me show my screen. Let me know when you can see it.
We can see it now.
All right. Good thing you're here, Melissa. So hopefully now you can see the data.gov.uk website. It's all very flashy and new. And if we click on the Data tab and look at data sets, you can see that there are absolutely tons and tons of interesting data sets taken from the government of the UK and either specific to the UK or England or Wales or Scotland. So I was searching through here looking for something interesting, and what I was looking for in particular was something that was going to show off all of the functionality of Power BI, a reasonably sized data set that's got some interesting things that I can talk about, and crucially has a kind of geographical theme as well, because I wanted to be able to use Power Map to plot the data on a map. And what I was able to do, what I ended up working with, was road safety data. Now, every time there is an accident, at least in England and Wales, the police record a lot of information about that accident. And what we've got here on this page is a list of all of the downloads for road safety data from data.gov.uk. You can see that it comes as a series of zip files, and inside each zip file there is a CSV file. And I've got information broken down by year, a single download for every year. And I've got three main large data sets. So for each accident that's recorded, I have an entry in one of these accident files. And I've got accident files for 2005 to 2012. For each accident, the police not only records a whole bunch of information about that accident, including, crucially, the latitude and longitude, the date and time, but they also record two other things about each accident. So they record details about the casualties for each accident. So one accident could involve multiple casualties, and for each casualty we have things like the gender, the nature of the casualty, and so on. And one accident could, of course, also involve multiple vehicles. So we've got another set of files that contain all of the information about each vehicle associated with an accident. So we've got quite a lot of rich data here. So I very laboriously downloaded all of these files, unzipped them, and I put them in a directory on my hard drive, which hopefully you can see now. So if I just open up the accidents folder, you can see that I've got one CSV file for all of the accidents in England and Wales for each year. Now if I open up just one of these files in Notepad++, you can see that it's a pretty boring standard CSV file. We have a unique identifier for each accident, the accident index. We've got the latitude and longitude of the accident, so we know the precise location of the accident. We know the police force involved, because there are multiple different police forces in the UK. We know things like the accident severity. Was this a fatal accident, for example? The number of vehicles involved, the day of week, the time. We know some other information like, for example, a local authority, which local government area was this in. We know the name and number of the road, because every road in England and Wales has a name and a number. We know the speed limit that was enforced. We know whether we were close to a junction or not. All kinds of other really, really interesting stuff. Great for the data scientist in you. I suspect if you're a policeman having to fill out a questionnaire about every single accident here, with filling in all of these different details, it's probably pretty boring to do, but great for anybody that wants to analyze this data. So I downloaded all of these CSV files. The next thing I needed to do was to load this up into Excel. I'll show you my actual workbook in a moment, but I'm going to give you a brief overview of how it's possible to load all of the data from all of these files into Excel. So you probably know, if you've used Excel at all, that you can load data from a CSV file directly into the worksheet. The problem with doing that is twofold. First of all, you can load data from one CSV file into the worksheet, but if you've got multiple CSV files, that's going to be multiple steps. The other problem is, if you have a very large amount of data, that will lead to a very large worksheet, and you may even go over the maximum allowed number of rows inside a worksheet. So to get around this problem, I used Power Query, and I loaded the data from all of these CSV files via Power Query into the Excel data model. Now you may be asking yourself, what is the Excel data model? Well, in Excel 2013, we still have Power Pivot. But a lot of people think about Power Pivot in the way that it was with Excel 2010. In Excel 2010, Power Pivot was a separate download, and the Power Pivot add-in, which you downloaded, contained all of Power Pivot. It contained the Power Pivot database engine, the XVelocity in-memory analytics engine, and it also contains an Excel add-in that provided a user interface to work with the data inside that engine. The difference between Excel 2010 Power Pivot and Excel 2013 is that the engine behind Power Pivot in Excel 2013 is now native to Excel. It's present in all desktop versions of Excel. The Power Pivot add-in still exists. Unfortunately, it's now only available if you've got Office Professional Plus, but now it's literally just a user interface. It's a user interface that allows you to do exactly the same thing, but it allows you to build models inside Excel, but it's a user interface on top of a native bit of Excel functionality. This database engine behind Power Pivot, and this is what's now officially called the Excel data model. So the new good practice with Excel 2013 is that if you're loading large amounts of data into Excel, don't load them onto the worksheet, load them directly into the Excel data model, which is the engine behind Power Pivot, so you'll be able to aggregate it more quickly and do all kinds of cool calculations. So that's solving the problem of data volume. The next problem is, of course, I have a whole bunch of CSV files that need to be loaded up. So what you can see here is my folder containing all of my accident data. And just to give you an idea of what I had to do to load all of this data into Excel, here is an empty Excel workbook. Let me just close that. Here is an empty Excel workbook, and if I go to Power Query, I can certainly load data from a CSV file, but the best option here is to use this from folder option. So if I go to Power Query and say import data from a folder, what I need to do is I give Power Query the name of the folder that I want to import data from, and I click OK, and the Power Query query editor will open. Now, Power Query is part of the Power BI suite, and Power Query allows you to get data from all kinds of different data sources, and as you can see down here, either load the data into the worksheet or to the Excel data model. Now, like I said, in this case, in my real example, I wanted to load data to the Excel data model, and there we go. But this is actually a very large amount of data. We've got well over 1 million different accidents across all of these different CSV files. So I don't want to load it anywhere just at the moment, and I certainly don't want it to start loading by accident because it takes several minutes to load in, which I don't have. So for the purposes of this demo, I'm just going to uncheck both of these boxes. But anyway, at this point in Power Query, I can see a list of all of the CSV files in my accidents directory. And of course, what I want to be able to do is I want to be able to load all of the data from all of these CSV files. I want to treat them effectively as a single data set. And this is something that is very easy to do with Power Query. When you've got a folder full of CSV files like the one I've got here, and you use this From Folder option in Power Query, at this point your source is actually just the list of files in this folder. Each file has a content column associated with it, and if we look more closely at this content column, you can see it contains a list of values that are called binaries, and we've got this special icon up here on top of the content column. If I press this button, something wonderful happens. All of the data from all of these files is combined together into a single data set. In fact, Power Query has done a lot more of that, more than that. So if we take a look on the right-hand side here, in Power Query, we're able to apply multiple steps, multiple different types of transformation to our data source before it gets loaded into Excel. We can actually see what's happened here as a series of different steps. So my first step was to go back here just to point Power Query at this folder of CSV files. When I clicked this button here, Power Query realized that all of these CSV files, all of these binary files contain data that could be combined together. And that's what happened then. It was able to say, well, let's combine all of these CSV files, treat them as a single binary file. Let's import all of these as if they were a single CSV file. So now I've got all of the data from all of the CSV files in a single data set. The next thing is the first row of the CSV file contains header information. So I'm going to say here, let's take that first row and use that as the column headers. That's again something that Power Query in the current build does for you. And then Power Query comes in and says, well, let's infer some types. So coming from a CSV file, all we've got is text. But Power Query is able to take a sample of the data from these CSV files, and it's able to apply a data type to each one of the columns. And there are a lot of columns here, so I'm glad it's done that for me automatically. So I can see by clicking on my longitude column here, it's recognized that as a number. But if I go across here to the local authority highway code, then this is recognized as text. And indeed, there isn't really anything else that I needed to do to load all of the different data, all of the data from all of these different CSV files into my Excel data model. Power Query really makes it very, very easy to do all of this. So let's discard that. Let's close that workbook. And now let's go back to my real workbook. here are all of the Power Query queries that I used to load data in. You can see that the accident data set has got 1.355 million rows in, so there are just almost 1.4 million accidents in the time period we're looking at. I've got a casualty table with 1.8 million data sets in, and a vehicle table with almost 2.5 million data sets in. Now I've moved the data files for this, so these queries aren't going to work anymore, but they do behave in exactly the same way that I've just shown you. If we go into the Power Pivot window and have a look at the data in some of these tables, so if I was to go and to grab the accident table, you can see that there are all of the columns that I showed you in that CSV file earlier in the and also in the Power Query query. What I've also done is I've hidden a whole bunch of columns as well. There are a lot of columns in here, and it's always good practice when you're working with data in the Excel data model inside Power Pivot to hide the columns that you're not really interested in working with, because that's just going to make it much easier to be able to find the columns that you do want to be able to work with when you start playing with this data in a pivot table. Now the next question that I had to answer, or the next thing that I had to solve in my ETL, is that a lot of the columns in these tables basically just contain codes. So for example, the police force column here contains numeric codes. There's no indication as to which police force each of these codes actually refers to. And to do this, I had to download yet another Excel workbook from data.gov.uk. And this data guide contained one worksheet for every single possible different code column that I would have in my accident, my casualty, and my vehicle table. So for example, for the police force column, where in my accidents table I've only got numeric codes, here on this table on this worksheet in this workbook, I've got the translation between the code and the label. Now I could have used Power Query again to load the data directly from this workbook, but in actual fact what I ended up doing was pasting all of the data from these tables here onto the Dimensions tab of my workbook, just to make it easier to look up some of these values in case I wanted to send this workbook off to anybody. And then with these tables of data formatted importantly as tables in my Excel workbook, I was able to take these tables and add them to the data model by just clicking on this button. So I've got two different ways of loading data. I either use Power Query to get all of the CSV files, merge them together, load them to the Excel data model, or I can just paste these tables of data into my worksheet, and then once they're formatted as tables, I can click the Add to Data Model button and load them directly into the Excel data model. Let's close that. And having done all that, I've got now tables not only for my accidents and my vehicles and my casualties, but for things like police force and all of the different road surface types that are recorded, or all of the different types of junctions that we might be at when we have an accident. This means, as you can see, we have an awful lot of tables in our Excel data model. And if I go to diagram view, you'll be able to see that it's pretty complicated. Having loaded all of these tables, I needed to create relationships between these tables. No relationships were created by default. So I had to drag from, for example, the light conditions column of my accident table onto the code column of the light conditions table, so I'd be able to create a relationship and be able to analyze accidents by the particular light conditions. So pretty straightforward stuff. The other thing that I needed to do as well, actually I've forgotten another data source, is that I needed to import a date table. In order to get hold of a date table, and of course if you've ever worked with Power Pivot, you know that it's very important to have a date table to import data to use with your data. I went out to the internet, I went to the Azure Data Market, and we can go to the Azure Data Market here. The Azure Data Market is Microsoft's place to go and buy and sell data. So if you've got some data that you want to sell to other people, the Windows Azure Data Market is the place to go. I go to the Data tab, and one of the data sets in here, in fact one of the free data sets that you can download and use, is the DateStream dataset published by Boyan Penev, and in here you can get hold of pre-built date tables. So my date dimension table, I just use the basic calendar English table, and I filtered it so that I only had the years 2005 to 2012, and I imported that into the Excel data model again through the Power Pivot window. So I have a date table. So I was able to import all of these different tables of data, set up relationships between them, and in some case set up some hierarchies as well. So in this case on my date table I've got a calendar hierarchy that will allow me to drill down from year to month to date. And at that point I'm almost ready to go. I could go away and create a pivot table from all of this, and indeed I have a pivot table here, but I wanted to do things maybe a little bit more formally. So what I wanted to be able to do was create some measures. Now the basic types of measures that I created were pretty straightforward. If we go to the accident table, I created a measure called accident count. And accident count is very, very simple DAX. You can see the DAX definition here. I'm saying here's a measure called accident count, and the definition is count rows accident. So that just allows me to find the number of rows in the accident table, and that means that I can drop this measure into my pivot table and I can analyze the number of accidents by whatever. So if we go back to the pivot table here, let's delete some of this stuff actually before we go. So if we take some of these things away, if I find my accident count measure, I'm able to drop this into my pivot table, and there's my headline figure of 1.355 million accidents, and I can break this down, for example, by date. So if I find my date table, there's my calendar hierarchy that I've created. I can break this down by date, and I can drill down from year to month and see the number of accidents per month, and drill down from month to day and see even the number of accidents by day. And of course I can also use all of my other tables, all my other kind of dimension tables. So for example, if we were interested in, let's find accident severity, I can drag that onto there, and I can see that there were in 2010 1,731 fatal accidents, whereas there were 20,000 serious accidents and 132 odd thousand slight accidents. And we could take some other stuff like, for example, police force. So maybe if I wanted to just look at accidents reported to a particular police force, I could drag that onto here, and if we were to look at Thames Valley Police, which is my local police force, I can automatically slice that data, and I can see luckily there are only 71 serious accidents. The interesting thing here is you can see that in the time period that we're looking at, there's been a pretty big reduction in the number of fatal accidents over time, though interestingly the number of serious accidents has pretty much stayed the same. So this could be maybe due to better road safety. So all kinds of interesting things I can do here, and of course because I've created table measures that also allow me to look at the number of casualties, so let's take that away. We can compare accident counts to casualty counts. The trouble with a workbook that's this complicated, it can be very, very tricky to find the tables and columns we're looking at. So there's casualty count. I can look at accident by count by casualty count, and we could also do something like insert a pivot table. A pivot chart rather. And we look here, and here we can see the number of accidents relative to the number of casualties. We can go here and let's put in a trend line. Put in a trend line for this. One of the things I really like about Excel 2013 over previous versions of Excel is how easy it is to suddenly to work with charts. And you can see already from comparing the trend lines that the number of accidents is going down in relation to the number of casualties quite clearly. Let's get rid of that for the moment. Something else that I wanted to do as well was also do some DAX calculations. So if we go to the casualty table, if we look at casualties, I can find the casualty table. Oh, there it is. That's obvious. I've got some examples of some slightly more interesting calculations here. So what I've got here is my simple casualty count measure, which as you can see just counts the number of rows in the casualty table. The next thing that I wanted to do in a pivot table like this, if we were looking at casualties, was to say, well, I can see the number of casualties and it looks like it's going down, but really I want to be able to see a percentage growth or a percentage change from year on year. So what I was able to do was to use some DAX to be able to calculate the previous year casualties. So this is my previous year calculation. I'm taking my existing casualty count measure, and then I'm using the same period last year function to be able to shift all of the dates in the current year back 1 year, so I get the previous year casualties out. If I go back to my pivot table, this is what this calculation returns. So you can see that my previous year calculation here returns 203,950 casualties, and that is indeed the previous year value here. This is this, this is this. I was able to use this to get my previous year casualties out, and then of course the growth is this value, take away this value, divided by this value. And I created another measure to do that, my casualty count year-on-year growth calculation, which said give me my casualty count measure, subtract previous year casualties, and then use the divide function, divide by previous year casualties. Incidentally, it's very good practice to use the divide function here rather than just the divide operator, the /, because the divide function handles division by 0 and division by null. And of course, in this case, in 2005, we don't have a previous year calculation, so we don't want to see an error in this particular cell. And there you are, we can see the year-on-year growth calculation. And this not only works for years, we can go down to the month level and we can see how much January 2009 is compared to the number of casualties in January 2009 compared to the number of casualties in January 2008. So by calculating the percentage share, we're able to get a much better look and see at what's going on. And then, of course, the last thing we want to be able to do is make this really obvious, really easy to analyze. Let's build a KPI. So in order to build a KPI from this, right-click, create KPI. Here's one already created. And this KPI says, well, okay, an absolute value of 0 is going to be neutral. If there is a 0% growth year on year, then that's not going to be good or bad. But if there is a greater than 2% growth, I'm going to say that's bad. And a greater than 2% decline, I'm going to say that's good. So I'm able to create a KPI like this. And now in my pivot table, I can get rid of that. When it decides it's going to wake up. All right, let's put the status column in anyway. So you can see that there is a more than 2% decline year on year at the year level. But if we were to look at the month level, you can see that for January 2011, there was actually a 12.15% growth based on the previous year. So building this KPI makes it very, very easy to see at a glance where the problem months have been, where there have been big declines or big increases in the amount of accidents. And I would imagine probably what happened with January and December 2011, we probably had some bad weather, which meant that there were just a lot more accidents than in the previous year, given that the year-on-year growth is much, much better. So that's my KPI. We can do pivot table analysis, and that's pretty useful. But the next thing I wanted to be able to do was start doing some more fancy data visualizations. Now, the obvious thing that you think of when you think of fancy data visualizations with Power BI is Power View, but it's a mistake to try and ignore all of the amazing things that you can still do in an Excel worksheet. So what I wanted to do next was actually build a data visualization that used native Excel functionality that's been around for a long, long time. And what I've got on this workbook is a visualization that has days of the week on columns and then months of the year on rows. And if we look at this, we can see what this is going to show, which days of the week have the largest number of casualties. I've got some slices here that allow me to change the data shown. And if we look at fatal casualties for the 56 to 65 age band, you can see there doesn't seem to be any set pattern at all. But if we go and have a look at, for example, the 21 to 25 age band, you can see that now, if we think about what days of the week have the largest number of casualties, Sunday and Saturday, I guess when the 21 to 25-year-olds have been out partying, getting drunk and doing all kinds of bad things, Saturdays and Sundays are clearly the worst days for fatal accidents. If we go to 26 to 35, you can see there's still quite a strong pattern, but maybe not quite so strong as before. 36 to 45, no pattern really at all here. I guess everybody's grown up and stopped going out drinking and driving. So how did I do this? Well, the way I did this was to use Excel cube functions. So Excel cube functions are the other way to get data out of the Excel data model, Power Pivot, into a worksheet. What I've got in each one of these columns is a cube member function that references a value from one of the columns in my table in the Excel data model. So up here, I've got my days of the week referenced. And down here, I have got my months of the year for 2010, 2011 and 2012. The way I created this was using a pivot table, and then once you've got a pivot table, if you click inside your pivot table and select OLAP tools, convert to formulas, this will convert your pivot table to Excel cube formulas. So that's the easy way of creating Excel cube formulas. That's what I did here. And at the intersection of each month and each day of the week, I used a reference to a measure that in this case is hidden, which is a percentage share measure, which shows for each day of the week the percentage share of the casualties for the month. And if I go up here, this is my casualty count percentage of all days, saying give me the casualty count and divide that by the casualty count for the grand total for all days of the week. So I was getting a percentage share value in each one of these cells. But actually I didn't want to show the percentage share value at all. What I wanted to do was just generate this heat map effect. So in order to make the cell values invisible, I used an Excel trick. If you click on Format Cells, you can use a custom format that is just 3 semicolons, one after the other. And if you use this format in a cell in Excel, it makes the contents of your cell disappear. So I was putting percentage values inside a cell and then making them disappear. And then, in order to show the values in a different way to create this heat map, what I was using was conditional formatting, and I was able to select all of these rules, these particular cells in here, and apply a conditional format that said, okay, format these cells based on their values and format them with the lower values almost completely transparent and the higher values as dark red. So this was how I was able to create this heat map effect inside Excel. It's still linked back to the data in the Excel data model. You can see that when I change the slicer, there's a slight delay while the new values are brought back. But it just shows you what can be achieved in terms of fancy data visualizations without even using Power View. Having said that, of course, I wanted to be able to use Power View as well. And I started having a look for some interesting data that we might want to investigate. And what I did was take, while Power View decides that it's going to get ready, there we go. I took my data and I was able to present it as a series of bar charts. And I spent a long time looking through the data to find something interesting. And what I'm doing here was having a look at the number of casualties by day of the week. And each one of these charts, as you can see, is a day of the week. And then inside each chart, I am using the age band of the casualties. So I'm looking at the number of casualties by age band, by day of the week. And from this, you can see quite clearly that there is a spike on every weekday in the 11 to 15 age band. So I thought, okay, this is particularly interesting, what's going on. And I will go to the school children tab. So the 11-15 age band is clearly what we're looking at. I created another very similar chart, but now these bar charts, they're still broken down by day of the week. But now on the x-axis, what I've got is the hour of day. So now what we're looking at are casualties by day, by hour of day. And in Power View, I've selected the age band 11 to 15. I'm narrowing things down to casualty class pedestrian. And if I clear my filter for the moment, we don't want to look at any particular month, you can see that there are some very, very clear spikes where children in the 11 to 15 age band who are pedestrians are being hurt in accidents. The first spike is at the hour 8 a.m. So this is accidents that took place between 8 a.m. and 9 a.m. And the second spike is in the time band 3 p.m. to 4 p.m. 8 a.m. to 9 a.m. is in the UK when kids travel to school, because school generally starts at just before 9 a.m. and 3 p.m. to 4 p.m. in the UK is when school finishes. So these are kids on their way to school and on their way back from school. At least that's what I think. If we slice the data by month and we look at, for example, August, when all of the kids are on holiday, the pattern completely changes. We're still looking at children in the 11 to 15 age band. We're still looking at pedestrians, but there are spikes in the middle of the day. This is August when all the kids are on holiday. If we go towards looking in September, the spikes are back. So I think this is pretty clear proof that school children have a lot of accidents on their way to school and even more on their way home from school. Don't know why the way home from school is so bad. Maybe it's because they're tired or they're not paying so much attention on their way home from school. So these are my examples of some funky types of data visualization that you can create with Power View, and shows you how you can kind of manipulate the data inside Power View, filter, explore the data very, very easily. The final part of my demo, I wanted to show off this data using Power Map. Now, obviously the accident data is clearly got a geographic angle, and I wanted to be able to do but I wanted to be able in Power Map to be able to do some types of analysis that I wouldn't really be able to do anywhere else in, for example, Power View or the Excel worksheet. So with Power Map, what I did was I said, well, let's not look at all of the data. And one of the reasons why I said that is because with 1.3 million accidents and 1.8 million casualties, Power Map really couldn't handle those kinds of data volumes, or at least not do so very smoothly. So what I said was, well, let's look at a particular subset of the data. And what I wanted to do was look at just data for one road. And the road that I chose was a road called the M4. The M4 is a motorway. It's the equivalent of a freeway in the US. The M4 is one of the most busy motorways in the UK. It starts in the middle of London and it goes west across England and then through to South Wales. So I chose it because it's a very busy road. I chose it because it has some very busy sections and some much, much less busy sections. And I also chose it for another reason that I'll explain in a moment. Now, I needed to do some data preparation work in order to be able to work with data from the M4. Unfortunately, Power Map at the moment doesn't allow you to filter the data dynamically. So even though I had all of the data I needed already loaded into the Excel data model, what I needed to do was create yet another Power Query to filter the data even more. And what I did here was basically do the same as I'd done before. And if we look at the code for this query, load up all of my accident data, combine it, but then filter it. So this is the important bit of code here. I'm saying look for motorways where the road number is 4. This means that I was able to isolate all of the accidents on the M4. So I was able to load this up as a separate data set into the Excel data model. And of course, having loaded that data into the Excel data model, you're able to go to Power Map, launch Power Map, create a new tour. I'll leave my existing tour intact. Wait a few moments while it catches up. Find my M4 table, and we've got the latitudes and longitudes already. So there is latitude. Power Map has realized that it's a latitude. I've got longitude. Power Map has recognized that as a longitude. Click Next. You can see that it's already able to plot those accidents as a single blob on here. And I'm able to, for example, put the data on a map. Now, this is each individual accident, which is interesting if you're interested in the location of each individual accident. But in my case, I wasn't all that interested in looking at individual accidents because there are an awful lot. What I was interested in is looking at which were the most dangerous sections of the M4. Now, you would be able to see this by, for example, zooming in and looking in a lot of data, looking at a lot of detail each individual accident. And you can do that like this. But what I was really after was actually the number of accidents in each small section of road. So after I'd loaded all of the data from the M4 into the Excel data model, what I then did was created a calculated column that took the latitude of longitude of each accident and rounded it to 3 decimal places. And of course, once I did that, if we delete this layer, sorry, I want the layer pane, but I want to get that layer manager. Let's delete that. Now, instead of looking at individual accidents, what I could do is take those rounded latitudes and longitudes. So if I say rounded latitude, rounded longitude, click Next, and I find my M4 column. Now I can take a measure that says number of accidents, put that and drag that as a graph, and rather than look at individual accidents, I can see the total number of accidents for each small section of road, which I think is a lot more useful. And this then allows you to see, because I plotted this bar chart along the length of the road, I can see very easily from a distance which are the most dangerous sections of road. Now, let's keep the height, but let's change the thickness a little bit so that we don't have charts that are too big. And let's change to a theme where we can see, sorry, and show map labels. And so from this theme, we're able to now see exactly where we are on the map. And the biggest spike that you can see is over here. This is at the junction of the M4 motorway and another big busy motorway, the M25. If we make it a little bit thinner, ever so slightly, you can see that actually the largest number of accidents is not on the junction itself, which is over here. And I can remove that. So if I remove the layer quickly, here is the junction of the M4, which is going east to west, and the M25, which is north to south. There's the junction shown on the map. If I put the accident count back on, the number of accidents peaks about half a mile or a mile west of the junction, which is presumably where everybody coming from the west is trying to get into position to change lanes to get into the right lane to get onto the junction of the M25. So I was pretty pleased by this, and I thought, great, we can now look at the number of accidents per section of the M25. But then I thought, well, that doesn't actually tell me what the most dangerous section of the M25 is. Because after all, there could be a really large number of accidents down this end of the M25 because this is where the largest number of vehicles are. So what I then did was go searching on data.gov.uk and download a different data set. You can also, in addition to get all the accident counts, get information about the amount of traffic on each section of road in the UK by year. So I downloaded that, I loaded that into the Excel data model, I filtered it again by the M4, and then I had, of course, a table that contained the average number of vehicles on the road per year for each section of the M4. So this is my M4AADF table. So for each section of the M4, between each individual junction, I've got a number of vehicles per year. The next thing is, how do I know which section of the M4 each individual rounded latitude and longitude is in? This was the tricky bit. What I ended up having to do was to find a website like this, and this website uses Google Maps. It allows you to search for places in Google Maps and then put a push pin anywhere on the map and find its latitude and longitude. Now, there's only a very limited number of junctions on the M4. I did this for all of the junctions on the M4, and then I put that in a table in Excel, and I've got I had all of the latitudes and the longitudes for that. Now, the interesting thing is here, I really only needed the longitudes. Part of the reason why I chose the M4 here is that it goes from east to west, and each junction on the M4 is further west than the previous junction. And that made the calculation to take each individual accident and its latitude and longitude and place it between two junctions very, very easily. So once I'd got the latitude and longitude, and specifically the longitude of each accident, and then when I had the longitude of each junction, because each junction is further west than the previous junction, it was possible at least to write a calculation that said, give me the name of the junction, which is the junction whose longitude I am just a little bit more than, but less than the next junction. So I was able to associate each accident with a section of road. I'll show you the DAX that I used to be able to do that. So there's my M4 junction, sorry. If I grab my M4 table, the number of vehicles on each section of road was a little bit of DAX that looked like that. Pretty horrendous. But then I was able to say, well, let's weight each accident by the number of vehicles on that section of road, and creating an accident weighted column rather than counting the number of accidents. I was able to, with this accident weight column, sum up the accident weights using a measure and create M4 weighted accidents. I was able to go back to Power Map and say, well, here, instead of looking at the overall number of accidents, let's get rid of that, and let's look at instead the weighted number of accidents. And you can still see that there is a spike around by the M25 junction. But if we go further west, you can see, wow, there is a really big spike down here. So this is exactly what I was looking for, a section of road where there isn't actually much traffic, but proportionally there is a much, much greater number of accidents taking place. And if we zoom in, This is by junction 41 of the M4 in Port Talbot in South Wales. So I can tell from this that this is the most dangerous section of road on the M4. So that brings me to the end of my actual presentation. One of the last things that I wanted to be able to do but couldn't when I actually built my presentation was upload all of my data to Power BI. Here I've got an Office 365 subscription, and this is my Power BI site. When you load your Power Pivot workbook up to your Power BI site, you're not only able to connect to this workbook and browse all of the visualizations in the browser, and they all work. Everything that I've done here except for Power Map works in the browser. So there's my school children analysis. Here is my dangerous days analysis. That all works in the browser. Notice the browser is Chrome as well, so it's not even dependent on Internet Explorer. I've got a pivot table here, and I can even click and edit this pivot table. Click. I can say, click in here, and I can just drag, and I can drop. So click OK. And I can do not everything that I do in my pivot table, but I can do pretty much anything that I want. I can do, well, quite a lot of different analysis. So if we just look at 2012 here, I can now see my year-on-year growths inside the browser broken down by casualty type, and I can see that there are, for example, a big drop in the number of casualties, people who are driving mobility scooters. So I can analyze data in my browser, but more than that, what I hope to be able to do, if I'm lucky now, is to be able to analyze, query my data using natural language. Because once you've uploaded your workbook to your Power BI site, Q&A becomes available. And Q&A is a feature of Power BI. Once you've uploaded your data to the cloud, you're able to type natural language questions and then have it interpret those questions as queries and display the result. Now, if I was to say, show accident count by accident severity, I can type that in, and you can see that it's interpreted my question as a query, and it's built effectively a Power View report and chosen a bar chart to show this. I could use a pie chart. Pie charts are bad practice from a data visualization point of view, but you can see that I can choose a different type of visualization, and I can even filter the data that's on here. So Q&A is great. It's not always able to interpret my queries. So for 2012, no. For the year 2012, no, I don't want to count. You see that it isn't able to get absolutely everything, but in general, accident year, it's able to almost do a good job by time. Okay, all right, it's not going to be able to do that. So anyway, hopefully you'll be able to get some interesting results out. I wasn't able to practice this earlier because it just crashed. That brings me to the end of my session. Hopefully you've seen a couple of interesting snippets that show you how I built my demo for the Power BI competition. And if you've got any questions about this or anything Power BI related, I'm happy to answer them now. Melissa, are you still there?
I am. it's so cool to see, all the different pieces that you needed to gather to put this together. And I was thinking more about times a year and when accidents are and that type of thing too. So, lots more to dig into with your example. So, so we don't have any questions at this moment. So I'll give a couple of minutes and see if folks want to ask any. Okay, I got one. It's not a question. A big golf clap. Very nicely done.
Thank you very much to whoever asked that question.
It was a Chris. Yeah. All right, let's see. All right, one question. What happens with CSVs with different column formats are loaded at once? When?
So I guess the question is, what would happen if my CSV files didn't have quite the same structure? That's probably what the question is.
Right.
Power Query does its best to try and merge data together, but different things will happen depending on the different structure of the files. In general, I think the click button that I showed you to merge lots of different data files together is only really going to work effectively if the files have got exactly the same structure. Otherwise, you may well end up with errors.
It's kind of like standard ETL practices, right? You got to have it in the same.
I mean, if you want
the
to
same.
Exactly. If you want to get your hands dirty with a bit of M, in fact, if you wouldn't even need to write some M, it would be possible to import each CSV file separately as a separate Power Query, and then you would be able to, inside each individual Power Query, delete any of the extra columns, make sure all of the column names are the same, the data types are the same, and then when you've got all of the individual CSV files loaded as separate Power Query queries, it would then be very easy to create a final query that merged all of the data from those other Power Query queries together. So you're not just limited to getting data from multiple CSV files. You're able to actually take multiple Power Query queries and merge all of the data that they return together into a single mega query. So that would probably be the way you'd handle that.
I have a general level question. Do you think that by corporations using BI, that the governments may make data more available, allowing departments and users, to be able to go and get that data? It looks like in the UK it's broadly, available. But do you think that'll drive it?
Yes, I think so. There's certainly a big open data movement in the UK. Interestingly, even though you would think that the big corporations would probably be the people who wanted to use this open data most, and maybe they are, in public at least it seems that it's the small startups that really want to be able to use open data. The people developing mobile apps that, for example, maybe would show, using this data, it might say, if you're driving along, show the accident black spots in my area. It seems to be the people who are building the kind of small startup companies that are pushing the most and are the most vocal for getting hold of open data. The other interesting group of people who are very, very vocal about getting the open data are journalists. There's a big movement at the moment for something called data journalism. And publicly, a famous example of that in the States would be a guy like Nate Silver, but actually there are a lot of journalists in different newspapers around the world who are open to the idea of using data to understand different political or news stories, and open data like this is very useful to them to be able to find out what's going on with government. Understand when government is making the right decisions or when things are failing. And it seems like the journalists themselves are actually making a very big contribution to open data.
Yeah, to further that question, the attendee asked, do you think that corporations themselves would go more would tend to go more towards an open data model.
Oh, corporations themselves making
Within,
their data
yeah.
open.
Yeah. Within, within the corporation, but
working within the corporation, yes, I would hope so. I mean, obviously there are some big, reasons of competition and data privacy that would mean that corporations would never want to make their data available for free publicly. But, I would hope that within a corporation, and I think Microsoft hopes the same thing, there is more openness with making data available to everybody to use. Obviously, there are dangers with that, and I'm sure all data professionals are very well aware of those dangers. There are the dangers of, data being used incorrectly, people misunderstanding, people modeling the data incorrectly, doing calculations that are incorrect, people using out-of-date data. But if we've got technology that can help people overcome those issues, then I think the greater availability of data within an organization and greater availability of tools like Excel 2013 and Power BI within an organization should increase the uptake of data-based decision-making, I would hope.
okay, yeah. So we're also thinking this will probably help drive the new role of data scientists, or maybe a data science departments in corporations.
Absolutely.
Yeah, definitely.
I mean, I'm already seeing BI center of excellences being established inside companies, which are staffed by people who are not IT. They're more of those kind of business analyst people with business skills. They're now not just kind of left on their own inside the organization. They're being grouped together in these special departments, and I guess they're going to be in a great position to try and press the IT department for greater openness of data.
Right. That's a great point, because if folks are looking for those type of roles, they may want to look for those keywords of center of excellence. I've been seeing that a lot as well, in job postings and such.
Yeah.
Alrighty. That's all we have at this point, Chris. Thank you so much for taking the time to go through your submission. I'm sure it's been quite valuable to all the folks on the call, and as long as the quality comes out well, we'll be putting it on the Past Business Analytics Virtual Chapter YouTube channel, and I'll paste that into the window in a few seconds. But unless you have something else to say, Chris, I'm probably going to close out the call at this point.
No, the only thing I've got to say is thank you for listening, and I hope you enjoyed it.
It was awesome. Thank you.
Cool. Thanks a lot, Melissa.
Thanks.